Alright, so this video is about finding the domain of a function. So let's take a look at different looking functions and then how you go about identifying them. So let's say you have so you have f of x. Let me fix that again. So we have f of x equal to 5x. Okay, and I want to know the domain. Okay, so one way that I think is the fastest way is to visually see what this looks like on a graph. So let's take your calculator. Okay, let's pull up your calculator here, and let's graph f of x equal to 5x. So turn on your calculator, go to y equals, and type in 5x. So we'll type in 5x, right? And then just so that everybody has the same graph, let's do zoom and click on 6, which does a 10 by 10 count. So here it is. So here is our graph. And so when we're writing the domain, we are asking ourselves, what are all the x values that literally make this graph? Okay, that means how far do I go to the left in making this graph? What x values do I need to go to create this graph? And same way going to the other way. You know, what x values do I need to the right that will keep making this graph? And so it looks to me like this goes on forever. So that means I'm going to keep needing all the x values in the negative direction. And this also goes on forever. So that's telling me the same thing in the positive x direction. So for my domain, I would probably go ahead and say that it is parentheses negative infinity all the way to positive infinity. And that's my domain for this particular function. Let's do another one. Let's say we're doing f of x equal to 1 over x minus 2. Okay, so let's graph that one on our calculator. So we'll go to y equals, let's clear out the equation that's there. Okay, and then I'm going to type in a 1, so I'll put 1 in. And then this means division, this denominator line here. So we put that there. Now to say x minus 2, we don't just put in x, we have to do a parentheses because we're including x minus 2. Okay, because we want all of this in the denominator. If you just say x, then it's just going to be 1 divided by x and then subtracting 2. And then you won't get the right graph that you're looking for. Now that we've already done zoom 6 already once, we just hit graph and we can see the exact setup. So here we're asked for the domain again. So the domain looks like all of the x values in the negative direction, because this keeps going on and on and on. So I'm going to need all the negative x direction values, and as well as in the positive direction. I'm going to need all these. The only one that I'm not needing, it looks like it's right at x at 2. And you can see that right here in the actual function. So if I was to take the denominator x minus 2 and set it to 0, and if I add 2 to both sides, I get x equal to 2. And so that's telling me that I cannot put 2 into this particular function. Because if I do that, I get an error, because 2 minus 2 is just going to give me 1 over 0, which is undefined. And we can't do that. That's undefined. Okay, so we can't have that. So that's the reason why you can't have it at 2. So when you're looking at the graph here, we see that it can't be 2. So in that case, to write our interval notation, we'd have to do it in 2 parts. We have to say parentheses negative infinity all the way up to 2, but we can't include 2, so we have to use a parentheses. And then that's a union with 2 all the way up to positive infinity. Okay? Or on the homework, they may not have you put this in as a choice. It could be you could just write all of them except for x not equal to 2. And so this, you might see this in either choice selection as you're doing the homework online. So just to be sure about that. Alright? So that's the setup for that. So now let's take a look again at another problem. Let's say we're doing f of x equal to the square root of x. Okay, what would be the domain for this one? So take it again. Let's go back to the calculator. Go to y equals. Let's clear out that equation. We'll put in the square root of x. You can see the square root symbol is right here. It's in blue. So that means you have to hit the second button and hit the x squared. And we get this. And so then you type in an x. And now you hit graph. Alright, so taking a look at the graph, it doesn't keep going to the left. It literally stops right here at the origin. And so we know that that means we would have to be starting at 0 for the domain. That's our lowest value. And then it keeps going in the positive x direction because this line keeps going. So our domain for this particular one would be a bracket 0, comma, all the way to positive infinity, parentheses. Let's fix that again. Okay. So, okay. And so that would be the domain for that particular one. And so I'm trying to think of any other examples that come up in the homework and the quizzes, and I don't see any other different problems in that. We can do this one. Here's one more we can do. So we have f of x equal to 1/2 x squared plus 1. Okay, let's do that one. So we go to the calculator. So go down to the calculator. Okay, we type in the equation. Okay, so I'm going to clear this one out. It's 1 divided by 2. Okay, and then we have x to the power of 2, which is squared, right? And then we're going to do add 1. Okay, and now we'll graph it. So here is what it looks like. Okay, and so the domain, I'm just going to call it D. Okay, D. That will be, well, starting from the origin and going out. Where does it stop? Well, this line is continuing to keep going. It's not stopping, and so it's going in this direction forever. So I now know that my my lowest point is going to be negative infinity, and then it looks like it's going to be that way going in the other direction because this curve keeps going as well, and so that's going in the positive direction forever. So we now know that that becomes infinity for this one. And if I wanted to do the range for this particular function, I could see that, oh, it looks like it starts at 1. That's the lowest y value in my graph, and then it keeps going on and on forever because I need all these y values in both directions to continue the graph. So this one is going to be bracket 1 comma infinity. And this is how you calculate out your domain or your range for the functions looking at graphs. So if you are given an equation, a function, then this is how I think is the best way to come up with the domain and the range.